There are places on Earth that seem to whisper secrets to those who listen. Helgoland is one of them. This tiny German island sits in the North Sea, battered by wind and waves, surrounded by red cliffs and seabirds. For centuries, Helgoland was a haven for fishermen and a battleground for empires. Yet 100 years ago, it became the unlikely birthplace of a revolution in science. Imagine standing on Helgoland's rocky edge, the salt spray on your face. The sea stretches in every direction, endless and mysterious. It was here, in 1925, that a young physicist named Werner Heisenberg, suffering from hay fever, retreated to escape pollen on the mainland. Seeking relief, he found something far greater, a new way to understand the universe. Helgoland is not just a geographical curiosity, it is a symbol of isolation and inspiration. Here, far from the bustling cities and noisy debates of his colleagues, Heisenberg gazed at the stars and dared to rethink the very fabric of reality. Today, Helgoland is a quiet tourist destination, but its legacy is woven into every smartphone, laser pointer, and MRI scanner. The story of quantum physics begins here with one man's restless mind and the relentless power of nature. Werner Heisenberg was only 23 when he arrived on Helgoland, plagued by allergies and uncertainty. The year was 1925. Physics was in chaos. Electrons, light, and atoms refused to behave. Old rules no longer worked. Scientists were desperate for answers. Heisenberg, alone in a small boarding house, decided to ignore what couldn't be seen and focus only on what could be measured. Nights on Helgoland were stormy and sleepless. The wind howled, and Heisenberg scribbled equations under a dim lamp. He struggled with the mystery of electrons, tiny, invisible particles that seemed to follow rules unlike anything known before. In a flash of insight, he realized he could describe their behavior using rows and columns of numbers, matrices, rather than neat, predictable paths. Matrix mechanics was born. Imagine a dance where each step depends on every other dancer. But you can't see the dancers, only the pattern of their footprints. Heisenberg's matrices captured the invisible choreography of electrons without ever showing their actual paths. It was radical and strange, yet it worked. Suddenly the chaos of the atomic world made sense. Heisenberg's breakthrough would soon change physics forever. By focusing on what could be measured, not what could be imagined, he opened the door to the quantum world. His nights on Helgoland proved that sometimes the best answers come when you're far from home and willing to see things differently. And now, quantum computers are on the horizon. These machines use qubits, quantum bits, that can be both 0 and 1 at the same time. They promise to solve problems that would take ordinary computers billions of years. Quantum physics, born on Helgoland, is reshaping our world in ways Heisenberg could never have imagined.
But quantum physics doesn't stop there. Consider quantum entanglement, a phenomenon so bizarre that Einstein called it spooky action at a distance. Entangled particles remain connected, even when separated by vast distances. This is not just a curiosity, it's the basis for quantum encryption, promising unbreakable security for future communications.
Take the humble transistor, the building block of every computer and smartphone. Transistors rely on quantum tunneling, a strange effect where particles slip through barriers as if by magic. This allowed engineers to shrink circuits and pack billions of them onto a single chip. The digital revolution was born, all thanks to a theory crafted on a stormy island.
Quantum physics didn't just stay on blackboards and in textbooks. It leaped into our lives, shaping the technology we use every day. Without quantum mechanics, we wouldn't have lasers. The beams that scan barcodes, perform eye surgery, and power the internet. Every time you swipe a CD or use a fiber optic cable, quantum rules are at work.
Yet for many scientists, the mystery is part of the magic. Quantum physics reminds us that the universe is not just a machine, but a place of endless wonder, a puzzle that invites us to keep questioning.
Quantum mechanics also connects us in new ways. Entanglement suggests that distant things can influence each other instantly, as if the universe itself is woven from invisible threads. This has led philosophers and scientists to ask, what is real? Is the world made of things or of relationships? The answers remain elusive.
The equations Heisenberg scribbled on Helgoland reveal a world where certainty is replaced by probability. We can never know everything about a particle, only the odds of where it might be.
Physicist Carlo Rovelli, who wrote a book named Helgoland, sees quantum theory as a lesson in humility. Nature is not what we expect. It is richer, subtler, more surprising, he says.
Nobel laureate Anton Zeilinger says, quantum mechanics teaches us that the world is much stranger than we ever imagined. It challenges our deepest beliefs. Particles can be waves. Cats can be both alive and dead, and cause and effect can blur.
100 years after Helgoland, quantum physics still puzzles and inspires. Leading scientists reflect on how it has changed our view of reality itself. The future is wide open. As we unlock the secrets of the quantum world, we may discover answers not just about atoms, but about ourselves.
All of this is possible because of the strange properties discovered on Helgoland. But perhaps the biggest mystery is the link between quantum physics and consciousness. Some scientists wonder if the mind itself might be a quantum phenomenon. Are our thoughts entangled? Does the act of observation shape reality? No one knows for sure, but these questions drive research at the edge of science and philosophy.
Quantum sensors are another frontier. These devices can detect the tiniest changes in gravity, magnetic fields, or time. They could revolutionize navigation, help us find new resources underground, or even spot earthquakes before they happen.
Quantum computers are making headlines, with companies racing to build machines that can crack codes, design new medicines, and simulate the universe itself. These computers process information in ways that defy logic, using superpositions and entanglement to solve problems ordinary computers can't touch.
The next century of quantum science promises even more surprises. In the end, Helgoland is more than a place. It is an idea, a lighthouse shining across the sea of discovery, guiding us toward the next great breakthrough.
The adventure is shared by everyone who looks up at the night sky and wonders what makes the universe tick.
The search continues, fueled by the same spirit that drove Heisenberg on those stormy nights. Scientists around the world now build on the foundation laid on Helgoland. Laboratories hum with lasers and supercooled atoms. Students learn about matrices and entanglement, marveling at the strangeness of it all.
Today, Helgoland stands as a symbol of curiosity, creativity, and the courage to challenge the unknown. The journey of quantum physics is far from over. Each discovery raises new questions. Why does the quantum world look so different from our everyday lives? Is there a deeper theory waiting to be found? Will we ever unite quantum mechanics with Einstein's theory of gravity?
Helgoland's story is a reminder that great ideas can come from unexpected places. The island's wind and waves pushed Heisenberg to think differently and changed the course of science.
The universe is waiting, and who knows? The next big idea might come from a stormy island, a quiet laboratory, or perhaps from you.
So let us honor Helgoland and the restless minds who changed our view of reality. Let us keep asking, keep exploring, and keep dreaming.
One thing is certain, the spirit of curiosity that drove Heisenberg lives on. Every breakthrough starts with a question. Every discovery opens new possibilities. The quantum world is strange, but it is our world, a place where imagination and evidence dance together.
What new wonders will the next 100 years bring? Will quantum computers transform our world? Will we finally understand consciousness or discover new laws of nature?
As we celebrate a century of quantum physics, the adventure is just beginning. The questions that started on Helgoland now echo in every corner of science and technology.